Hello everyone, welcome to my channel, and today we're going to talk about limits. First I'm going to give you some of the definitions and theorems that have to do with limits, and then we're going to go on and explain what that means and go over some example problems that you might see on your homework or your exams, right? Okay, so for what is a limit? So first, limits have to deal with graphs, so I'm going to draw a quick little function here, right? And I'm going to say that this function goes like that, right? This is our x and our y. So what a limit is basically if we have some arbitrary number, a, and we say, okay, if we make x really close to a from either side of a on the function, let's call this function f of x. If we get really close to a, what is that number approaching, right? On the function, what is that number approaching as we get really close to a from either side? So how would we write that as a definition? So what we would say is that the limit as x approaches this number a, right, of our function f of x is equal to some number L. Meaning that as we approach a from either side, our function is going to approach this number L in our function, right? That is somewhat of a brief understanding or intuitive definition of a limit, right? Seems pretty simple. Now we have to break it down a little bit further, because now we're gonna have to ask ourselves, when does a limit exist and when a limit doesn't exist, right? So in our case, I'm going to write it over here, and there's a theorem for that. And we're going to write it this way. But how we're going to write it is the limit as x approaches that number a over here of f of x, which is our function, is going to equal to some number L if and only if. So if and only if, I'm going to put it here, the limit as x approaches a from the negative side, or from the left side of it, known as a left-handed limit, of the same function is equal to L, as well as a limit as x approaches that same number from the positive side, or a right-handed limit, has to equal, of the function x, has to equal that same number. So if the left-handed limit and the right-handed limit are both the same, then we say that there is a limit as x approaches a for that function. If these two do not match, the limit does not exist, okay? I have to keep that in mind. Now there's also a bit of a definition here that is in the textbook that you'll find might be overlooked quickly. But in order for this to be true, what we're doing is that we're making that x really close to a, therefore x has to be defined, or x has to exist around a except potentially at a. Now keep that in mind and keep that at the back of your head when we're doing problems. What that means is that a doesn't have to be defined in order for there to be a limit, right? We don't care about what happens at a, we just care what happens around a. So as we approach a, we care about what we get really close to a without actually touching a. We just say what we predict it to be or what we think is going to hit, right? That really takes care of all the theory behind it, and I'll go over what a left-handed limit is and a right-handed limit is. But basically all it is that the left-handed limit for that same number is you just take the number and make it really negative, or on the left side of it, and then you approach that a only from left to right. So from the left to right side, from the negative side, you approach it. And the right-handed limit is the same way, but you go from right to left. So from the right side, I would approach that same number, getting really close to a without hitting a, and you would approach that number, L, and you would put it down. So right now I'm going to put up an example problem show you how to figure out what a left-handed limit is, a right-handed limit is, and seeing whether that actually gives us a limit at L, all right? So I've set up the problem here really quickly. And what I want you to notice here is I'm gonna ask you first, we have this function, right? F of x. And you'll see that there's an open circle in the middle of it, meaning that it's discontinuous there, or that the point doesn't exist in the graph. So if you were to plug in x equals 5 for our function, we wouldn't get anything because it doesn't exist, right? And then we're going to figure out, the first question is the limit as x approaches 5 here from the negative side, or a left-handed limit. I want to know what the left-handed limit is here. And you're going to say, well, we're going to go from the left side of that 5, and we're going to get really, really close to it, right, without actually hitting it. And we're going to follow that graph to see what number it approaches. As you can see, as we follow it, it's going to approach to that number 7, right? But then we look at it here and we say, well, that 7 isn't defined in the function, so what do we do? Remember I told you earlier that we don't actually care what the output is of the function at the actual number that we're trying to take the limit out of. We just care what happens around it. So that's fine. We don't really care if it exists or not in the function. We just care what that limit is, or what that number is approaching, right? Kind of that limit. So as we trace the graph from left to right approaching that 5, we're going to see that the number is going to approach to that 7, right? So the left-handed limit is going to be 7 of this function f of x. Now we're going to go here and I'm going to say, well, what is the limit as x approaches 5 from the right side, or the positive side? A right-handed limit. So we're going to grab the function on the right side, and we're going to slowly get closer to 5. As you can see, it's also going to approach that number 7, right? And now my last question is here, what is the limit as x approaches 5, right? So first I got to figure out whether it exists or not. And that's where I got to go back to this theorem back here, where it states that the limit as x approaches some arbitrary number a of f of x only exists if and only if the left-handed limit and the right-handed limit exists. So then we go back to our problem, right? And we look at the left-handed limit and the right-handed limit. They're both equal to each other. Therefore, the limit at x equals 5 exists, and it is that same number. So it'll equal 7. Now we're going to go into a different problem where you might ask yourself, well, what happens if it doesn't exist? What does it look like when the limit doesn't exist in our graph? So I'll be right back. All right, so now that we have this problem, you're going to notice that the graph is a little bit different now, and it's broken apart. It's called the piecewise function. So it goes along here and it breaks apart, and this point doesn't exist in the graph, but it does exist over here, and then it continues on. I'm going to ask you guys what the limit is as x approaches 3 of this function, right? So again, if I ask you just this question, first we got to check if it exists. So in order to do that, we check first if the left-handed limit exists and the right-handed limit exists, and whether those are the same and they both equal each other. So even though it's not written there, I wrote it down here just so that I know what I'm looking at. And we're going to see, okay, we have f of x coming along here, and as we approach 3 from a really, really negative side, so from the left side of the graph, and we approach it, you see that it's come down to this 9, right? So it's going to approach this 9. Like I said, it doesn't matter if it exists or not within the graph. In this case, it doesn't exist. We just care what it approaches, what the limit is as we get really, really close to 3 from the left side. And now we compare it to the right-handed limit. So we're going to write the limit as x approaches 3 from the right side, so the right-handed limit, is equal to some number. And now we're going to do that. So now we're going to go look at 3 and go to the right side of it, and then approach that number and see what the output of the graph would be. So in this case, as we approach 3 from the right side, we're going to get really, really close to this 3. So the function approaches 3 from the right side. So something curious happened, right? If we want to figure out the limit here, we're going to check first if the left-handed limit and the right-handed limit are the same. In this case, they are not, right? The left-handed limit is 9, and the right-handed limit is 3. Therefore, since by this theorem, right, that we stated earlier, if these do not exist, then this cannot exist, because this only exists if and only if the left-handed limit and the right-handed limit are the same. So therefore, here it doesn't exist. We write D and E for short. And that is our answer here. And that is an example of a problem where the limit might not exist. So these are some of the basics to limits, and I'm gonna make another video about limits at infinity. What happens when let's say we wanna figure out what the graph approach is if we make the number really, really, really big, right, at infinity. And that's kind of the thought process that we're gonna go into in the next video. But in the meantime, if you have any other questions, please put them in the comments down below. It can be a question from your book, or it can just be a topic that you want me to cover that your professor or teacher might not have covered correctly. That's been your boy Nybrisk. Hopefully you all enjoyed. Let me know what you guys think. Like, comment, subscribe, do whatever. And I'll see you guys in the next video.